look at Maria's homework. She's got it all correct. I added some things at the bottom, things I haven't really explained yet. Okay, let's just run the whole thing first of all. Okay, so here's where she got the data from. Let's go look at the data real quick. Okay, here it is in a Kaggle. Now these people called it, it's a data set for polynomial regression. I don't know why they said polynomial regression, because okay, what it is here is okay. It's this. Let's write it down. So it's basically you take the length and width and height and species of a fish and predict its weight. Now, obviously, okay, a polynomial is something like this. It's something like, 2x. Oh, we can do this here with math symbols. Plus 4. Uh, Now that's a curve, right? Oh, it does work now, see? Look, if you put a dollar sign twice, it'll put this math formula in the middle. Like this. See, they said it's a polynomial, but obviously it's not. It's a linear equation, right? A polynomial is a curve. Whenever you have the first number here, it has an exponent. That's a curve. You guys all have seen the graph of something squared, something cubed. Now, you could obviously tell if you know how long a fish is, how tall and wide it is, and then the species of the fish is important because it has to do with density, right? Certain kind of fish are heavier than other kinds. So this is all linear, right? You can just say multiply the first one times 2, the second one times 3. So anyway, so I don't know why they called it. This is really, this is linear, not polynomial. Here's the data. Okay, now I don't know what the different lengths are. Maybe, my dad had fishing boats. If you ever saw that movie Forrest Gump, did you see that movie?
Yeah.
Yeah.
Yeah, you remember that boat there? He had one, the same boat. So did my uncle, so did my cousins. And so I know a lot about boats. But anyway, so fish. So I think this length here probably is, like if you go across the back of a fish, that's called the dorsal. That must be one length. If you go across the stomach, that's called pectoral. Then you can go down the side, that's called lateral, I think. I think that's really what that means. So anyway, so we read in this data. Okay, now here is something that I changed below. But what she did is, okay, uh, you know, when you have words, okay, when you have text, you need to decide what to do with it. Here we just filter on it. A perch is a kind of a fish. Now we'll show below there's other ways to handle that. Okay, so we're gonna basically here we make this okay, we select from fish data set the type of fish. This is a perch. Print it out. And also I would use display here, Maria, use display. Then it makes it nice and formatted. See? Like that. Prints for Numpy, basically.
Yeah.
Okay, now the weight, okay, what do we want to predict? See, let's write down what we're trying to do here. Okay, what is our plan? See, okay, so, before when we did simple linear regression, we just said y equals mx plus b. You remember that? The point is okay, we know x, we want to predict y. Okay, when we use single linear regression or simple linear regression, there was one value for x. It's the same thing though. When you're dealing with multiple linear regression, we use a capital X because this is an array like this. It's an array of x1, x2, x3, and so forth. It's multiple things. And then b is still going to be a single number. It's called bias. You remember we called it the y-intercept when we were dealing with one independent variable because it's the point where the line crosses the y-axis. But when you deal with this, you've got multiple dimensions. So it's mathematicians call it real space. It's not three-dimensional. It's more than that. It's one for each independent variable. It's not something you can draw, but still bias. Bias means add to, right? We're going to come up with this, right? The training, what does the training do? It uses mean squared error to find, okay, in this case, it's going to find m, now we use capital M, equal to A, B, C, and so forth. It's the same thing. So this trains the model. These finds the coefficients. It'll find the bias. You know what they even call it intercept, which is kind of funny because it's not logical to call it that. So it's the same thing, and it looks almost the same way. So now let's go down. So obviously, the weight is what we want to predict, right? We know that this is a perch. It's okay. Well, here's the data that we already have, right? We know it weighs 5.9. That's not kilograms. I'm a fisherman, and believe me, that would be a very big perch. Look at that. That perch is a small fish, Who knows what this is? I don't know. It must be ounces. That's a American British thing. Okay. So this is going to be our Y. So she's just printing it out. Now, this step here, let's write some instructions. When you say this, okay, what is this? What kind of object is this? Is a pandas what?
Series?
Correct, series. So when you go values, it throws away, if we were to print this out, right? If we were to go like this, we would see it has indexes, right? It has the numbers on the side. But if we do values, that's just going to convert it. It converts it Numpy array. Because we only want numbers here. So we're going to do this. Values. There you go. It's a Numpy array. Like we can say what shape does it have. 56 values, okay? So she's calling it weight array. I would, when I'm doing this, I would use X and Y, just because when you do X and Y, well, below you you'll see we use we use what's called X train and Y train and X test and Y test. But if you use the same names that's in the documentation and the examples, then you can copy code. You won't have to change anything, right? You have to remember here that weight array is really Y. Okay, now we reshape it. Okay, so uh, what shape does that have? Okay, well, this is what we talked about here. This makes it one-dimensional array. I mean, what if we look at this? Uh, so it's just a requirement. It's a requirement of the fit method. The fit method is the training method. So here we print it out. Now, okay, here. Now, the size array has the things that you need. This is going to be X, right? These are the things that we need in order to uh, train on, to calculate the weight. We need to know the length, 1, 2, 3, the height and the width. Now she didn't have to do any. She didn't have to do any kind of reshape because she just did it like this. So if we say, what's the shape of size array? It's going to be in the correct format. The correct format was what? Correct format for the, we'll see it's the reg fit method is shape samples features. Remember, see, one other thing I got to say is, okay, when we work with what is called supervised data, that means it has labels and features. How does facial recognition work? When you walk down the street and you're a criminal and it took your camera takes your picture, how does it know who you are? Well, the labels, it has police photos. The labels are pixels of your face. And sorry, that's the features. And then the labels is name of the person. So here we have the features. Here are these things, or X, or all the values of X. And then the labels is Y. Okay? Uh, so here she just print the first element, right? This is the first row. This is the first column. We could also do, can we do info? I don't know if you can do info. I don't think you can do info on a Numpy array, can you? You do that on a data frame. No, can't do that. I forget. Uh, maybe it's got mean, something like this. Yeah, it does have mean. Okay, it does have some functions. Okay, it doesn't give us a count. Well, by shape, we get the count. Okay, here we go. So we know we got 56 samples or data points and 5 features. Now, we just import our model Then we run this. We create the model. Okay, this creates the model. A programmer would say it instantiates an instance of the linear, well, object. Okay, that object now called reg has methods. One is fit. Okay, the format is we say reg, we say fit, we say x and y. Okay. Now it does return parameters, but we don't list any here. This one seems to update itself, right? There's no parameters. So we run this and it says, here's the coefficients. Look, notice we get 1, 2, 3, 4, 5 because we have 5 features. So it used mean squared error. It looked for the least squared error line, right? It calculated this line. Now, we cannot draw a picture of this line. Why can we not draw a picture of this? We can only draw pictures of one-dimensional, that's a line, two-dimensional, that's the Cartesian plane, and three-dimensional space objects. We cannot draw a four-dimensional object. We definitely cannot draw a five-dimensional object. Maybe they exist. They do exist in mathematics, but you cannot see it. Okay, now, predict. What is the predict going to do? It just takes the input and it's now using these numbers here to make predictions. Okay, now Maria is using this nice feature. I call it a nice feature because it really is. Column stack lets you put the input, there's the X, here's the Y, and here's the predictions. Lets you put them all together and print them out. So you can see here, oh, like look at this one. See this one, the weight was 180. It predicted 208. Pretty close. Now, how close was it? Well, we look at R squared. Okay, we can't, mean squared error doesn't really mean anything. That number doesn't really mean anything. But this one does. R squared 0 means your model is not at all accurate. R squared 1 means it's 100% accurate, meaning it can predict everyone with exact answer. Okay, did people follow me? You understand this so far?
Yeah.
Yeah.
Okay, now here's what I did to make some changes. Okay, first of all right, this one's going to be a little bit difficult to understand. But look at this. Okay, so let's just write it like this. Suppose we have well, we can see it here. It's easier to see. But let's see here. Suppose we have a data set like this. We have a data set with a A, A, and then B, B, and then the C. Okay, if we want to use this text in our model, which we definitely do, remember, why did I say it was important to know what kind of fish it is? You know, some fish have heavier than others, just so we do need that information. Now, what Maria did was filter on that, so we can make this called a a one hot array, which is like this. This would be a 3. Actually, we do. Let's see. It's actually done like this. The first one will be 1, 0, 0. The second one would be 1, 0, 0, 1, 0, 0. Then the next one's going to be 1, 0, 1, 0, 0, 1. You see why? Because here we've got, you know, that shows a A, that shows a B, and that shows a C. So now we can do math against it, right? I mean, this we can multiply this by a coefficient, and it will make sense. Okay. So anyway, here you can see it here. So I do this thing here. I don't know why they call it this. Get dummies. What a dumb name here. Oh, I called it zip. So here I called it zip because I was using zip code. That's what Americans call postal code. So see, so I said take the species, one hot, and code it. Look, so see how many brim we got? See how many smelt we have? See? So it added these 1, 2. Okay, that made this data frame. Then we use pandas concatenate to add the two together. Axis equal 1. We want them as columns, not rows. Okay, and then it's adding here, right? So this is one hot coded. We can look at it like this. If I just go one hot. See, there it is. See? That's taking that text information, the species, and then converting it to a number. But a number that means something. It's converting it to an array. Now, having done that, I can throw away the text. So I get rid of it. Okay, now, if we look at the data frame, yeah, I'm using DF. See, Maria, I went back to using DF. You try to use DF and X and Y just because it's easy to understand if you use the same names all the time. So here we go. Now we have everything that we need. Weight. Why do we still have weight in here? Maybe I get rid of it below. So, okay, we got everything, including species here, although it's been converted to this. Now, everything's a number, right? So all I got to do now is just say values. And then I have this input X with 13 features, right? There's 13 features because we say df.columns. There's 13 of those. 159 rows. Now, I just checked here to make sure I didn't get it backwards. So here, look, the first one says 242, 23, like this. So I did X0, show the first row. It's the same one, see? So I didn't rotate it or anything. Didn't mess it up. You have to be careful about that. Now, Y is this? Is we take the weight, And then I got rid of the weight because I don't need the weight in the input. I don't need the weight because weight is what we want to calculate. Now, but anyway, so now we run this. Now, here's the important thing that I need to point out. Okay, look. Test and train data sets. The rule is, okay, divide your data into test and train data sets. Now here I use 20% for the test size. So just rule of thumb, use 80% for training data, and 20% for test. Now, we can do that, but we don't have much data, do we? We've only got 159 rows. If you got 5,000, it's easier. You know? If you have 10, well, you sort of have a problem. But the goal here is okay. Goal is to avoid what's called overfitting. For example, think of it like this. You know what a survey is, right? Like if you go around Ukraine and you ask people, what's your favorite food, right? And they all say, I don't know what food that you like, ice cream. Okay. We do that based on a sample, but if you ask every single person, all of them in Ukraine, then it's not statistics. You've talked to everyone. So you have to be cognizant or careful about when you're working with data not to overfit. Overfit means your model works perfectly, but it's only really working well with this data, you know? Um, okay, so we train on the training data. Okay, so we've used 80% of it, right? And then we make predictions on the test data. I mean, you could think of it like this. You could say, okay, let's talk to everybody in Kiev, ask them what their favorite food is. Then let's go to Odessa and make a prediction. See? That's a more logical thing to do. Just how it works. Okay, so we use this tool called from scikit-learn called train test split. Random state, I don't know what that means. But here, we just take X, we take Y. We tell it the size of the test. And then we say create these 4 data sets. Here's X, here's X, here's Y, Y. But we have train and test. Okay, now look, we're going to train the model on the training data, right? See? Then it comes up with these coefficients. It's using scientific notation again. And the intercept. Remember, you can put like a little N here and it'll put a blank line, make it easier to read. Okay, now we do our predictions on the test data set. You see the difference here? So this is going to return 159 predictions, which is in here. We can look at Y preds. There's our predicted weights, okay? And then here's the mean squared error, 100% accuracy. Okay, now, I want to show you something here. Now, you remember, okay, what does this predict do? It's simply doing this. You could write it on a pencil now. right? This says prove that y equals mx plus b. So here I take what's called Numpy matrix multiplication. I take the coefficients, I multiply it by the first row, and then I add the intercept, and I get this value here. Now I put the first row in here, and I get the same number. You see? That's all prediction's doing. It's just taking the coefficients, multiplying it times the data, and adding the intercept.